Hello, my dear Java learners. Welcome back to our channel. Today, we are diving into a super important and fascinating topic in the Spring framework, dependency injection. You might have heard this term a lot, and it can sound a bit complex, but I promise you, by the end of this 5-minute tutorial, you will have a clear understanding of what it is, why it is so powerful, and how to use it in your Spring applications. Dependency injection is a core principle that makes your code more modular, easier to test, and much more maintainable. We will cover the basic concept, see how Spring implements it, and look at some practical examples and best practices. So, grab your virtual notebooks, and let us begin this exciting journey. Before we understand dependency injection, let us first understand the problem it solves, tight coupling. Imagine you have a car class, and this car needs an engine to run. Without dependency injection, you might create the engine object directly inside the car class, like this, engine is equal to new engine. This approach means your car class is directly dependent on a specific engine implementation. If you ever want to change the type of engine, say from a petrol engine to an electric engine, you would have to modify the car class itself. This makes your code rigid, difficult to test independently, and hard to reuse. This direct creation of dependencies within a class leads to what we call tight coupling, which is generally considered a bad practice in object-oriented programming. Now, let us introduce the elegant solution, dependency injection. Instead of the car creating its engine, what if someone else, an injector, provides the engine to the car? That is precisely what dependency injection does. The car class simply declares that it needs an engine, and an external mechanism injects that engine object into the car. The car no longer cares how the engine is created or what type it is, it just uses the engine it receives. This makes the car and engine classes loosely coupled. One common way to achieve this is through constructor injection, where the engine is passed as an argument to the car's constructor. This way, the car class relies on an external entity to provide its dependencies, making it much more flexible and testable. Spring Framework takes this concept of dependency injection and automates it beautifully. Instead of us manually creating and injecting objects in the main method, Spring's inversion of control container handles it for us. We simply tell Spring which classes are components or beans using annotations like @component for a class or @bean for a method, and then use @autowired to tell Spring where to inject a dependency. When the application starts, Spring scans our code, creates instances of our components, and automatically wires them together based on these annotations. This means you write less boilerplate code for object creation and management, allowing you to focus on your business logic. Let us see a practical example using Spring annotations. While dependency injection is powerful, it is important to follow some best practices and avoid common mistakes. A frequent mistake beginners make is mixing manual object creation with Spring's dependency injection. For example, creating a new engine inside a @component class when you should be letting Spring inject it. This defeats the purpose of loose coupling. Another pitfall is not understanding the Spring container's role. Remember, Spring manages the life cycle of your @component beans. Always prefer constructor injection over field injection. Add auto-wired on a field because it makes your dependencies explicit, helps with immutability, and makes your classes easier to test without the Spring container. Constructor injection clearly states what a class needs to function correctly. Excellent work, everyone. We have covered a lot today. To quickly recap, dependency injection is a design pattern where a class receives its dependencies from an external source rather than creating them itself. This leads to loosely coupled, more testable, and maintainable code. Spring Framework automates this process using annotations like @component and @autowired, managing your application's components within its inversion of control container. Remember to prefer constructor injection for clarity and testability. Keep practicing these concepts in your own projects to truly master them. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java and Spring content. Happy coding, and I will see you in the next video.